All right, hello everyone. Welcome to today's discussion. In today's discussion, I want us to learn about how to connect this. What I have here is I have a Swarm board, and then the Swarm board is used for satellite communication with a space-based system. So we already know the Swarm project for satellite communication, and the idea I want to set up today is for a non-terrestrial environment, an environment where terrestrial communication like ground plane communications are difficult to come by. So let's say a place where there is no network, that is how you call it, but non-terrestrial terrestrial, the no terrestrial network is the technical term, and all you have is satellite reachability, and Swarm allows for communication over their satellites at every time by sending very specific messages. We are also very familiar that the Swarm board is also used for sensor motions, taking sensor information as interface, GPIO interface for taking sensor. So for example, if you have if you have a greenhouse where you want to measure humidity, where you want to measure other factors on the farm where there's no communicator, Swarm board allows for a GPIO communication. Basically IoT device allows for that kind of communication to pick up these sensor informations and then send them over the satellite where it gets to a Swarm board, and then from the Swarm a Swarm hive where you can actually download your information. Good. Sorry about that. So in connecting to the Swarm board, all that it just requires is you have a USB connection to your laptop, and there is already Swarm has a Python program they've written to control the Swarm board for you to send and receive messages over the satellite communication. But that's not what we are discussing today. Today we want to discuss a scenario where we can connect the Swarm board to a QT-PY through a serial connection, and then we were able to make the QT-PY have Wi-Fi access. So Wi-Fi means that in the environment you can set up an access point, or even the QT-PY itself can be a self-access point. You can build an access point inside it called the STA station solution, and then wherever that your laptop is that you are connected to the Wi-Fi, you can still send commands, remote commands to the QT-PY, and the QT-PY will instruct the Swarm board through the serial communication for the Swarm board to still send messages over the satellite and receive messages, and also vice versa. You receive the messages, the Swarm board, when it receives messages, will send them to the QT-PY, while through the serial connection, while the QT-PY will send those messages that it has received from the Swarm through your Wi-Fi connection to, let's say, your laptop, to your phone or whatever. And this solution we'll be building based on doing two key important things on this, which is the building the access point, the Wi-Fi connection, and also a web server on this, so that we can do that communication. But today we want to do the setup first. So in the setup, what I have here is basically a green solution. I have I have the Swarm board, I have the QT-PY, I have a solar panel here. So the solar panel, I have a battery, a DC battery here as I get a solar. So I'm looking at where there's no national grid, so all you have is a solar panel. So from the solar panel, so the first you have to do is to do the setup, and then I will take the receive connection. So on the Swarm connection, there is a port here called the RX. So I'll connect it right here to the RX, and then the RS comes to connect to the TX. That's, I'm connecting the serial connection for the QT-PY. So it comes in and then connects to the TX port. Okay, and then I'll take another cable connection and then connect this time around the TX. Okay, and then that will connect to the RX of the Swarm board. Beautiful. All right, so the next thing I got to do is to connect the grounding. So I'll connect the grounding of the QT-PY is fine on this pin. There is a document about the connections for the QT-PY. All those I'll put them on my GitHub, so you can always have access to it. Then that connects straight up to the grounding. Okay. All right, then the next thing I want is I want to get power connection onto the solar. So the solar is already charged, so I just have to just connect it to the battery and then have my solar come up. And then once my solar come up, what I need is I need to get a USB. I need a USB connection. I need a USB connection to connect to the USB port on the solar all the way to the QT-PY. And once I do that, I'll be providing the QT-PY with power. Okay, then the QT-PY is actually not doing anything. It's just 5 volts at 3.3 volts is enough. And then I need to use the QT-PY to power the Swarm board, which is also a solution that if you go Swarm also recommends or approves of. So I'll connect the VIN ports, which is also mapped here, and I'll connect it straight to the VIN port over there. And hala, you can see the Swarm board has started blinking. So this time QT-PY is powering the Swarm board. In addition, the receive pins on the Swarm board is connected to the transmit pin on the QT-PY, while the transmit pin of the Swarm board connects to the receive pins on the QT-PY. And of course, I also connected grounding. And the Swarm board comes with a GPS login system that is able to hook onto the GPS so that the satellite can communicate. It comes with the antenna doing UHF, and then also has that connection over there for communication with the satellite. So we are fully set up. What we are supposed to do right now is through this connection, the USB here, I'm going to write a code. Okay, so I've written a custom made code which I'll share on my GitHub using C++, where the code is doing two things. It configures the QT-PY to connect to a wireless access point that I have here, which is local. And then from the wireless access point, it also I build a web server on the QT-PY, so that anytime I connect, I don't need to use the USB anymore. Just with the Wi-Fi on my phone, just connect to the IP address that is on the QT-PY. I will be able to send serial commands through the QT-PY to the Swarm board. So that's the goal of this. So three things: connect the Wi-Fi, configure the Wi-Fi, configure the web server, and they also configure to send and receive serial communications between the Swarm board. And this type of solution is key because you do understand that the Swarm board and then the antenna needs to be in the open, and to send information from you, the human being, to this device. You can't always be in the open. Maybe you are in the lab environment. That is a scenario I have. So from the lab environment, how do you access the QT-PY remotely, the Swarm board remotely? And that is to make the QT-PY have Wi-Fi connection, then set it as a web server. So that's great. Thank you for being here with me. I'll pause the video, and then in my next session, I'll take you straight to my laptop where I show you how we wrote the code, and then be able to have those serial connections. Okay, so see you in my next video. Thank you so much, and then I think that's all for now. And please subscribe to my video. Thank you. And if you have any questions, just let me know. All right, so welcome back to the training. And previously, all right, so this is the line of codes that I have written for the QT-PY. the QT-PY. The whole code I've written here is about 26, break them down into 26 key areas, which I will explain, after which I've also uploaded onto my GitHub account. I'll share the code with everybody who wants to do Wi-Fi connection to the Swarm M138 board. So the whole code is based on C++. I wrote it in C++ for the Arduino platform, and then it also requires loading certain libraries to the Arduino. For those of you who are very conversant with Arduino platform, I already have Arduino running. I'm talking about this one. Yeah, this platform very easy to download and all that. If you have any idea, you can always contact me. Two key libraries I'm using: the Wi-Fi.h library, which I import into the Arduino, and then I have the web server. So I'm putting a web server and then the Wi-Fi into the Arduino. And then what I'm using the ESP32. The idea is I want to build a Wi-Fi connection and also create a web server on the ESP32, and through this interface I'll be issuing commands from the ESP32 to be able to speak with the Swarm board and also get responses from the Swarm board. Okay. So as you're in the C++ program, I'm importing these three libraries. The first is the Arduino library, the Wi-Fi library. I'm also importing the web server library. The next is to create the web credentials. These values basically this. All right. So it could be anything in your Wi-Fi, whatever that you have. This is just a access point that I created myself. So we have the Wi-Fi SSID, and then we have the password to it. The next is to create a web server. My web server I'm creating, so all these C++ programs will be compiled on the ESP32, which I showed in the previous video. On the ESP32. So listen, on port 80, I've defined certain variables that will actually accumulate a serial output to the Swarm board. Whatever I'm sending from the QT-PY to the Swarm board, I want to see the serial output, and then whatever response that I'm also output from the Swarm board, I also want to see a serial output for it. Okay, and I have a third part which specified for data received. So this one will contain the logs files as well, but this is specifically for just the data I want to receive. I want to filter the kind of information. These two are roughly going to do the same. The difference is that one of them contains log files, which I do not need, so I just had to run this one to give me the specific one that I want. And then the baud rate type is 115200. This is what Swarm recommends for their board. If you want to communicate with their board, this is the line rate that you want to do. So a C++ program that's introducing this in there as the baud rate, and then that's the selection. Then the first thing I do is to connect to the Wi-Fi. So I have this code, Wi-Fi begin input the SSID, and then based on the password, then connects to the access point. And then once it connects to the access point, it prints the status that yes, it's connected to the access point. And then I also do have that. I also do have the serial printout that is fully connected to the Wi-Fi point. So that's all for, it's very simple code here to get connection to the Wi-Fi point. So once the Wi-Fi is connected, I have to set up the web server by getting the IP, setting up the HTTP get and response messages over here. So I have also commented, so then with that, and then the server then starts, and I have to begin and then also start the web server. So that starts the web server for us, and then it prints that yes, web server is started. Okay, so and then all this also, I have to, once the web server is started, I need to wait for the serial interface to come up. So the serial interface where every after I've running this, all the responses coming from ESP32 will be issued to the serial interface. So the serial interface basically printing that yes, it's initializing with a Swarm board. That's the serial. Remember, I showed you those two connections over here on my this connection, that serial setup that I showed over here. That is what I'm setting up over there. The serial connection between the serial and the ESP32 and then the Swarm board. Okay, good. Then what I have to first check is if I've received any data. The Swarm board is said that periodically is received messages coming from the Hive. So it's a connection between the client. It's a client server architecture. So once you purchase the Swarm board and then purchase the contract to send messages, when you send message over the satellite constellation, it gets to a Swarm Hive, which is hosted by Swarm, and then from there you can have cloud access to that server to get information, also send for. So it's a two-way direction, send receive. So on site is what we are doing here. That on site in a non-terrestrial environment, how do we set up a Wi-Fi connection to the Swarm board to have remote control over the Swarm board from anywhere from our phone. We can send messages through the Wi-Fi, the access points that we have set up, and then be able to communicate with that. So that's for the serial to first to check if I'm getting any messages from there, and then basically going to display or serial output those to the interface for us, and then also for that. Then the next thing is I also have to check that the ESP32 is getting any data. So for example, on the ESP32 is which connects to the Wi-Fi. Okay, so from the ESP32, that means that my laptop first connects to the Wi-Fi, or your phone connects to the ESP32 through the Wi-Fi connection. And I have a web interface that will allow you to send the Swarmboard commands, okay, so that you can send. Some uses an MNE style of command style, so those are also share with you. Okay, so this is to ensure that we if we have received any data, and then it's going to display or show the data that it has received as well. So there's two directions. First, check Swarm from the Swarm board if you have any serial information or data coming from there, then print it out. And then second thing is check from the ESP32, which is connected to the Wi-Fi. If you have every information coming, then you also have to print it out. And then also you have to send that information that you get to the Swarm board. So ESP gets that information and then sends it to the Swarm board, okay? And also it displays that information from us, okay? And then also the IP address that is relayed through DHCP, because the ESP32 gets connected to the access point, and then the local access point has DHCP relay, so issues an IP to it. Because the IP is dynamic, I have issued that it should show the IP address of that IP, so that that is the IP that we will put in our browser. Okay, so we're going to put that IP in our browser and then be able to talk with it. So for example, if this is the IP, so this is the serial interface that I've built based on the code. So you can see that from the code, whatever command that I send over it's just gonna output for us. And then if you go down here, you have the response coming from the server. I have a couple of logs, and then all these messages are basically coming from there. So it is the web interface of this code and how it's working that I'm explaining in the background over here. Okay, good. So that web interface is an HTML. So if you are very familiar with how to build HTML syntax, CS and all that CSS styles and that. So I just built a CSS style to make the page more beautiful. It should the background color is over here. This HTML styles that I cannot take all the time to teach over here. If you are there, you can easily have it. So I have a CSS style to input, but the key concept that I actually want to drive across is how I've built a set that it shows the various kind of interfaces that are coming in, the connection, the serial connections, and then all that I'm showing them up here. Okay, good. So this part is for sending the data to the HTML code for sending the data to the Swarm board. So once the ESP receives the data, it's supposed to send that data to the Swarm board, and that is what it has here. So it has data sending, and then it also shows that test as well. And then the bit rates are also very select. Yes, I introduced this bit rate, so because bit rates baud rates, you can always be very select. So I have a button here, if I should show you, that allows you to select the various three buttons, and that is the code that you find over here doing good. So that's for the baud rates. Okay. Then the serial output window for the data sent to the board. So that I've also shown over here. Then there's a button to reset that. So this is what the HTML code that it displays this page, and I have a reset button to clear them up. So I can always have a reset button to clear the interface for you. Okay, so you can always apply this anywhere that you are. And then let's continue. So this side is all basically repetitions. You create the serial output to the Swarm board, serial output from the Swarm board to display the output onto the interface. Then I introduce a reset button onto it, and I have another also for the operations logs that I really not concerned about for now. And then also a reset button for that. Okay, then finally below I have a reference manual for some of the MNE commands that are accepted by the Swarm board. So once you know the various commands that the Swarm board require, so all these commands I've just put them in HTML formats, and then I have a JavaScript to also format it and then make it very nicely over here. So it's not a big fuss. The main thing is these are the key things that I'm bringing out. When it's forwarding to data, it should print out that information to the page. Okay, C++ program, and then when it gets the response, it should also output the response back to the page. And then also make sure that the baud rate is very important, that both the Swarm board and then the ESP32 are set to the same rate. And that's why at beginning I said that the Swarm project requires that you are in 11520 setup, and that does the redirection. So generally this is the code I share. Take a look at it. You can always customize it to how you want it to be. If anything, the key thing about this code, what this code solves, is the idea of working with Swarm M138 board, where you always have to connect the M138 board direct to your laptop, and at every time you want to do satellite com, you always have to carry your laptop and then the Swarm board all the way to the outside, where you have clear view of the side of the sky, so that you can communicate directly with the satellite. That is the thing I've solved. So by solving this, what I've done is that now we can keep the Swarm board and then the Swarm the dish all outside, and then just with our laptop through the Wi-Fi connection that you will set up in your environment, you can still send commands and receive. You can still send and receive messages from the Swarm board remotely. And the only device that I purchased in addition to the Swarm board was the ESP32, and I wrote a C++ code for the ESP32, which I've explained here, where all that it does is to provide set up a Wi-Fi access point to it, so that I can access the Wi-Fi connection, which my laptop will also be accessing at the same time, or your phone or whoever is connected to the LAN will be accessing at the same time. And then I also created the web server interface. So this beautiful web server interface that I've created right here, which to connect. So as soon as you connect with this IP, is the IP that was provided. So you can see that at this time I'm receiving messages coming from the Swarm board at all times. So these are messages, this telling me the running time that it just got boot up and then it's coming up. I can send some messages, like for example, if I want to look at the version that is running on the Swarm board, let's send that. And it says that I'll send, he has received it from the Wi-Fi. That's the message I've sent. And then it's us forwarding that to the Wi-Fi. Let's go down here. And once it's sent it to the Swarm board, the Swarm board has actually fed back, and then the Swarm board is running version 0.2. Similarly, I can use my phone. Take a look at the screen while I use my phone to send additional messages. So my screen, I'm also connected to the same IP address, and I can see all the chats that are being happening here. So whoever is on the LAN, we are sharing the same interface. It's like I've created a network management system. So the network management system to allow for communication with the Swarm board is what I've created. And wherever that you are, you can always send message. So if, for example, if I send, let me send a message that is not necessary. The goodness, let me see if I can have goodness, and then come over here and then just watch the screen over there as I send, and then see if you get that message over here. So I'll send that message, and if this page takes some time to refresh, and then I just refresh, so you can see this is the message I just sent over the phone because I've connected to the web server, and that message will try to send to the Swarm board. But the Swarm board address, yes, it shouldn't respond because that is not a language that the Swarm board understands. However, if I send any of the language that the Swarm board, for example, if I want to look at the current configuration of the Swarm board, I can send that, and that gives me the message that I'm looking for. Okay. Okay. So you can always reset the whole interface and then be able to still get the information that we want. And I have included a number of commands here. So all this is part of the C++ program that we've written. Thank you so much for joining, and bless you.